Controlling a computer with just your thoughts. It sounds like something straight out of science fiction, right? Well, it's not anymore. Today, we're diving deep into Neuralink, one of the most ambitious technologies of our time. We're going to break down how this company is building a direct link between the human brain and computers, and what that really means for the future of human ability. To really get what this is all about, you have to start with the people. Take Brad, for example. He has late-stage ALS, and his old eye-tracking tech would fail on him all the time, basically silencing him. But as this quote shows, Neuralink gave him his voice back, his ability to communicate no matter where he was. This isn't just about some cool tech. We're talking about restoring a fundamental human connection. And this really gets to the very heart of it. For millions of people, their brain is working perfectly, but that connection to the rest of their body, it's been lost. This is the fundamental problem Neuralink is trying to solve, rebuilding that bridge, not with biology, but with technology. So let's first get a handle on the scale of this challenge. We're talking about conditions like quadriplegia from spinal cord injuries or diseases like ALS, which can create this profound state of isolation. Just try to imagine this for a second. Your mind is perfectly clear. You're totally aware, but you can't move. You can't speak. You can't interact with the world around you. Your brain is sending out all the commands, but they have nowhere to go. This is the isolating, locked-in experience, and it's what has been driving the search for a solution for decades. And that solution is the brain-computer interface, or BCI. Now, the idea itself isn't new, but Neuralink's approach, well, it's a massive leap forward. Let's take a look at what makes it so different. Okay, this slide lays it all out perfectly. On the left, you've got the old way of doing things. Think clunky external wires coming through the skin that posed a huge infection risk. But then you look at the right. Neuralink's approach is a whole different ballgame. It's fully implanted and wireless. And instead of rigid spikes, it uses these flexible threads that actually move with the brain, and it captures way more data for much higher resolution control. So, the big question is, how does this thing actually work? Well, the whole system really boils down to 3 key breakthroughs. Let's break them down, one by one. First up, you have the link itself. Think of it as the command center. It's about the size of a coin, and it sits flush with the skull, completely hidden under the scalp once the surgery's done. This little device is what processes the brain signals and then shoots them wirelessly using just Bluetooth to a computer or a phone. And this is the real magic right here. This is how the link actually listens to your brain. It uses these unbelievably fine threads, way thinner than a single human hair. Each one is packed with electrodes, and because they're so flexible, they can move with the brain, which is absolutely crucial for minimizing damage and helping maintain a clear signal over the long term. It's a huge leap in biocompatibility. Now, you can't exactly implant these super delicate threads by hand, right? So this is where the final crucial piece of the puzzle comes in, the R1 surgical robot. It's basically a high-precision sewing machine for the brain, inserting each one of these threads with incredible accuracy while dodging tiny blood vessels to prevent any damage. So the tech is amazing on paper, but the real test, that's how it performs with actual people. So let's dive into the PRIME study and meet the first participants. Meet the pioneers. You've got Nolan Arbaugh, who went from using a stylus he had to hold in his mouth to playing online chess with just his thoughts. There's Alex, an engineer, who's now back to using complex design software. And we already heard about Brad, whose ability to communicate isn't limited by his environment anymore. These aren't just small improvements. We're talking about giving people their autonomy back. So just how fast is it? Well, the peak speed they've hit so far is 9 bits per second. Now, I know that number might sound a little abstract, but think of it as the speed of thought turning into action. It's a measure of how quickly a user can control a computer cursor just by thinking. And here's why that number is so mind-blowing. It's nearly double the previous record for any BCI out there. We're talking about a speed of control that is actually starting to approach what an able-bodied person can do with a mouse. That is a total game changer. Of course, this is brand new science, so there are going to be some bumps in the road, and there were. In one case, some of the electrode threads actually pulled back a bit, which caused a dip in performance. And this is the amazing part, the team was able to tweak the software, basically make it more sensitive to the remaining threads, and they not only recovered the performance, they actually surpassed it. It just goes to show how resilient and adaptable the system is. And believe it or not, just controlling a cursor is really only the beginning. Neuralink is building this as a platform technology, and the roadmap for what's coming next is expanding, and it's expanding fast. I mean, just look at this timeline. It's wild. In May 2023, they get the FDA's green light for the first human trials. Fast forward to September of the next year, and boom, the FDA grants them a breakthrough device designation for a vision restoration system they're calling BlindSight. And then not even a year after that, they get another one for speech restoration. The pace here is just incredible. And that's exactly why everything's moving so quickly, because the same core technology can be adapted for a whole range of different applications. We're moving way beyond cursor control. We're talking about potentially restoring sight, giving a voice back to people who can't speak, even controlling robotic arms and legs. The potential is just massive. So this is where we end up. Right now, the entire focus is on restoring what has been lost, an absolutely noble and life-changing mission. But it leaves us with this huge, profound question for the future. We are literally watching a technology repair the human condition. So, what will it mean for all of us when it has the potential to go even further?